Lesson 3 is on proving angle relationships. So yesterday we discovered angle relationships with our corresponding alternate and co-interior angles. What we're going to do today is we're going to look at proving them. So if you remember from the last chapter, when you go to prove a mathematical relationship, you're proving it for all possible values for all possible situations. So you have to use deductive reasoning. You cannot just use examples. So what we're going to look at first is constructing parallel lines. So the objective is to construct a parallel line to a given line using only a straight edge and a compass. So draw your straight line. So on the page, or actually if you flip to the very back of your workbook, there are some blank pages. And what you can do is just use one of those blank pages to complete this. So you're going to draw a straight line. On your straight line, so if I take a blank page, there's my straight line. On this straight line, you're going to mark a point that we're going to call point A. And it doesn't matter where you put point A on your line, it'll still work. So there's my point A. Then what you're going to do is you're going to draw a line through A that intersects it. So again, doesn't matter how I draw this, I just want a line that goes through point A. And then on this new line, we're going to draw another point, and we're going to call that point B. And the objective is going to be to draw a line through B that's going to be parallel to this line that we drew through A. And that's where the compass comes in. So you're going to grab your compass. And the instruction states, using a compass, construct an arc that's centered at A that intersects these two lines. So you're going to take your compass, and what you're doing is you're going to draw an arc, and that arc is just going to go through these two lines. And when it goes through those two lines, you're going to get 2 more points. And then we're going in alphabetical order, so I'm just going to label my 2 points as C and D. Then what you will do is you will take this compass without changing the radius, so without adjusting the compass, you're going to go up to B and you're going to draw an arc. So I'm going to have to make some movements on mine because I'm not going to have enough room to put it. So provided that you didn't start this at the top of your page, so if I extend my line out, now I can draw my arc that is centered on B, and then it hits this line. And we're going to label that point E. So what I have right now is I have a guarantee, because I haven't adjusted my compass, that the line from A to C, or the arc length, or distance, sorry, the distance from A to C is going to be the same as B to E, because I didn't adjust my compass at all. And then what I would do is take my compass and put it on point C, and I'm going to use my compass to measure out a distance between C and D. So I'm using my compass to find that distance between point C and point D. And I think I made my arc too small, so let's go back here. My arc going through B should be longer. And then I can go back and take my measurement here. Because my first step was to draw this line so that the distance from B to E is the same as the distance from A to C. And now what we're going to do is we've got the distance from C to D. So if I put my compass on point E and then draw another arc, that intersection point from C to this point here, or not C, E to this point here, which we'll call F, has to be the same distance as from C to D. And then the last thing that I can do is I can take my ruler and draw a straight line through B and F. And if everything has gone well, the two lines should be parallel. Which, of course, because of the screen does not turn out that way. Because the screen has distortion on it and I can't fine-tune my compass. But yours should look parallel, your two lines. Okay, so let's see. I went from here to here. So right here. This arc here has to be the same up here. So then that should be my point E. And then I make this measurement here. Oh, I have to make my point E longer. So I'm going to go back and fix that. Now if I draw the line from there to there, you'll notice that it's much better. So if I take these angles that I created, this angle here and this angle here, if you use your protractor to measure those two angles, what do you notice? Any reason why they're the same? What kind of angles are these? They're acute. They're on the same side of the transversal and in the same position. So we had co-interior, alternate, and corresponding. Co-interior means they'd both be inside. Alternate means they'd have to be on either side. Corresponding means they're on the same side in the same position. This was in the top left. This is top left. So these are corresponding. So what we have is the lines are parallel because the corresponding angles are equal. And that was from yesterday's lesson. So I'm going to give you a couple of minutes. What you're asked to do is use a ruler and a compass to construct a line through P that's parallel to QR. So I want this line that is going to be parallel to QR. So the hint that I'm going to give you, draw a line from P that intersects this line to start off with. So if we look at this, to draw my parallel line, the first thing that I'd want to do is draw a line through P that's going to hit Q. And it doesn't matter how that line is. It could be straight up and down, it could be angled. I just want a line that goes from P through that line QR. And then I'm going to take my compass, and with my compass, I'm going to take that point that I just created, and I'm going to draw an arc. And then I'm going to repeat that arc on P. Once I've recreated that arc on point P, I'm then going to use my compass to measure the distance between those 2 points. And this is the part that I want to do carefully, if I can. And then I will put that compass point on this arc that I created that intersected that line going through P. And then I'll draw another arc. And then I'm going to draw a line through P through that point that I just created. And when I do that, I should get my parallel line. So that's just doing some constructions. And the nice thing with these constructions is they are a form of a deductive proof, because I didn't tell you what kind of angle to draw. I didn't tell you what kind of line to draw. If I had taken this line through P that intersected Q and R, if I had gone this way, I still would have ended up with this line in the end. So it is a form of deductive reasoning. So now looking at the proving angle relationships. Deductive reasoning involves taking known relationships to prove new ones. So in the last lesson, what we were using was inductive reasoning, because we were taking the measurements of our angles and we were putting them together to determine the corresponding angles are equal, interior angles are add up to 180 degrees, alternate interior angles were equal. We use that with inductive reasoning. To do deductive reasoning, we're going to use the following proven facts. Okay? The proven facts are angles on one side of a straight line are supplementary to each other. So in other words, if I have this, and I have A and B, A plus B equals 180 degrees. This is a proven fact. We don't have to prove it. It's already been determined for us. So we can use that fact. The next thing that we're going to use is that vertically opposite angles are equal. So if I have two intersecting lines, the vertically opposite angles, so if this was angle C and angle D, would be equal to each other. That is a fact. I don't need to prove it, but I can use that fact to help me prove other things. And then the third one is that if I have two parallel lines, and we use the little arrows to show that they're parallel, and then I have a transversal, the corresponding angles, and there are several corresponding angles when I create this. I have this angle corresponds to this angle. This one would correspond to that one. If we make this one a star, it would correspond to that one. And if I make this one a box, those would be all of my corresponding angles. And the fact is that those corresponding angles are equal. That again is a fact. I don't need to prove it. It's already been proven for me.